Just like with rectangles, there are two methods for drawing circles, and the first is what I call an AutoCAD style approach, where we set the center point of the circle first, and then after that we type in a dimension. I'll type in 25 feet and press return. SketchUp completes the circle for us. On the other hand, we can draw a circle of some arbitrary size just to get it on the screen, and then immediately afterward we can type in a value and SketchUp will resize the circle. Unlike with rectangles, you can select the edge of a circle, go to Entity Info, and you can set the radius value here at some later date. I can make this say 30 feet, and the circle is resized. You can set the number of segments here or in the Measurements toolbar while you're drawing. I'll draw a circle. I'll set its size to 25 feet, and then I'll type in the number of segments right in the Measurements toolbar. I'll type 12s. That sets the number of segments. Now we have a 12-sided polygon. All curves in SketchUp ultimately are reduced to a discrete number of straight-line segments. You might say, well, if that's the case, why don't we just create a circle that has 120 segments? I'll do that. I'll type in 120s. And for all intents and purposes, this curve is perfectly round. However, we run into problems later if we push-pull this up to create a cylinder, and if we make this a handrail and follow it along a path, we're going to have an inordinate number of polygons in our model, and the performance of SketchUp is really going to suffer. It's very important that you balance the need for smooth curves with the need to be efficient when you're modeling. And so you just want to have as few segments as possible to convey the idea of a smooth curve. So for a circle, 32 is a good number. It depends on the scale that you're looking at it, though. If you're creating a rotunda that's round, you might need more segments. If you're creating a profile for a handrail, you might get away with 8 segments or 16, something of that magnitude. The difference between a circle and a polygon is very subtle. Let's take a circle, for example, and give it 6 segments. So it's actually a hexagon. I'll push-pull this up, and you'll see that the edges appear smoothed. We don't see a sharp division there, even though it's actually a hexagon. If we make a polygon with the same number of sides and push-pull it up, it has sharp creases here because the edges are not smoothed, nor are they softened. We can smooth and soften these edges manually by using the eraser tool with the Option key held down. So it's possible to convert a polygon into a circle, but it's really not necessary. It's nice to have specialized tools for these jobs. Circles have handles on their quadrant points, which allow you to resize them. I'll draw a circle over here, and I'll switch to the Move tool. If I grab the circle from some arbitrary point along the edge, I can just move it. If I grab the circle from one of its quadrant points, these are the 4 cardinal points, like north, south, east, and west. And they line up with these endpoints here. They're not on midpoints. If I grab it from a quadrant point, I can then resize the circle. And that works on all 4 quadrants. Sometimes it's tricky to figure out which one is the quadrant point, and it's helpful to look in a top view so you can more easily locate those points. This also works when you have a cylinder. You can grab the quadrant point and resize the cylinder. I might have better luck if I look at it from the top view. I can then make a cone in this fashion. Your point of view determines which plane you draw in. Most of the time you'll be drawing in the red-green plane. You can think of that as the ground plane. When I draw a circle, it appears down here. Notice that the circle is blue. That means that the axis is aligned with the blue axis, the vertical axis. If, however, I rotate my point of view and I try to draw a circle, it might appear in a different color. Here we have a red circle, indicating that its axis aligns with the red axis. If I change my point of view again, there'll be some point where the circle will turn green. This will allow me to draw an orthogonal circle to that red one. So now we have a green circle, a red circle, and a blue circle. There's another way you can effectively reorient the drawing plane without having to change your point of view. And it works like this. Draw a rectangle off to the side someplace, and push-pull it up. Now you have 3 reference surfaces that you can use to lock inferences. For example, I'll draw a circle, and I'll hover it over this surface. While I'm there, I'll hold down the Shift key to lock that as an inference. Then I can come over here and draw a circle. In the same way, I'll go over this surface, hold down the Shift key to lock that as an inference, and I'll draw another circle. Finally, I can lock the ground plane as an inference, and then I can draw a third circle.